kind of when we've been doing problems and there hasn't been more than one number recurring, or there's been multiple numbers that are in the fit, like both have 2. You want us to do both of those, and then I noticed in the book it says when that happens, it's no mode. So what would you prefer?
Well, here's the deal. Let me plug the mic in first too. The deal kind of is, there's no uniform definition of what multimodal is. So if you have a bunch of numbers, for example, Bert and Ernie, we'll come back to Bert and Ernie today. Bert and Ernie each had 5 data points, all of which were unique. We as a class said that means there's no mode because there's no repeating value. So it depends on how you define mode. Is mode the value that's repeated the most? Or is mode just the most frequently occurring value? Because those could kind of have different definitions. The one that's repeated the most, if each one occurs one time, they're all repeated once. Okay, so you could say they're all the mode in that case. So I promise not to give you tricky data sets, or like in-class assessments where you've got 100 numbers, all of which are different, and say, what's the mode? That's ridiculous. That's just being nitpicky. So as a simple definition of mode, look for the repeating values, and look for the one. Your data set was fun. Your key data set from last week, if I remember correctly, which is always suspect, but you had like 8 of you had 2 keys, and like 7 of you had 3, if I remember correctly. And we said the mode is 2, because 8 of you had 2, and 8 is more than 7. Whereas some books will look at that and say, yes, but they're very close, so we're going to call those both the modes. Let's not worry about that. Let's just say 2 is the mode because it occurred the most number of times. Is that a fair answer? Yeah. So don't worry about, if you write out your line of thought in something like that, I'll accept multiple answers too. But as far as keeping it simple, just look for the one that repeats the most. Is that fair?
Yeah.
It's a great question. And because you're going to realize some stuff here in this class, which is kind of a fun thing about probability versus statistics. Statistics is all stuff that human beings have created. We've created these measures, averages, medians, standard deviations starting today. We've made these things up, so therefore we've defined them to be a certain way. So we have to kind of obey by those definitions. Well, if your definition is slightly different than mine, we're going to have slightly different answers. And that's okay, as long as you've defined it well. When you get to probability, random numbers kick in and things just behave on their own. So there's less of this kind of word wrangling that we're doing right now. So Jess, as long as you're consistently using your own definition, I'm happy. You'll get used to that in this class. There's plenty of gray to deal with. So, but let's just go with the simple definition. Whatever one shows up the most, call that the mode. Please, Liz, Beth.
No worries.
No. I got a bunch of Liz's this term. It's throwing me off. Go ahead.
No worries. For E3, the mode answer that you had written down was 7 and 9.
Uh-huh.
Hang
Hang on 1 second, my friend. Let me call this. Oh, so this one, yes, this E3. The idea was I gave you a dot plot and just asked you to kind of ballpark the 3 values. And I said try to do it strictly using the dot plot, although that doesn't mean that you can't just default to doing it computationally. And maybe some of you did it both ways, and that's cool too. So the mode I had, you said I had 7 and 9?
Yeah.
I can see why. I probably would have put 2 in there maybe if I was working really quickly. Well, and so what's the problem with 7 and 9?
3 because 3 was repeated the most often, so I guess
3, let's see, 3 has
3
6.
dots, right? Or am I reading it wrong?
3's got 6 dots.
Oh, okay.
Oh, I see what you're saying, Beth. Excellent. You're modeling the frequencies, not the data. This is a good point, my friend. Thank you for bringing this up.
Okay.
What Beth just said, this is an exceptionally good point I had never thought of before. What she's saying is there are 3 occurrences of 5, 3 occurrences of 1, and 3 occurrences of 0. So she's saying the mode should be 3 because 3 shows up 3 times. Very, very good. The data that you're analyzing is on the horizontal axis.
Okay.
So that's what you have. Your answer has to be one of those horizontal values.
Okay.
I hadn't thought about that before. That's good. No, that's real good. So the mode is the 7 occurs, it looks like 8 times, and so does 9. So I'm going to call that bimodal. Jess says that's okay. And now 2, upon quick glance, 2 also looks like 8. So I might inadvertently say 2 is also a mode.
Okay.
But 2's only got 7. So the answer I'd be looking for on a test, lots of quotes, George Carlin's turning in his grave right now, would be 7 and 9. But if anybody put 2, I would totally let you slide on that because 2 looks almost as tall as 7 and 9. The fact in hand is you've got some interesting data going on here. You've got like these guys that are on the low end and these guys that are kind of on the high end. But that's an important distinction you made, Beth. We're seeing which data points occur the most. And 7 and 9 both occur 8 times, so that they're the modes. Good, thank you for that. I hadn't even thought about that. That's a really, really cool way of It's a cool way of thinking about it, and it's a good distinction to make sure we understand it.
Right.
That the data is what's on the horizontal axis. The frequency just is a shorthand way of keeping track of that. Good, very good, very good. Anything else? Please, just go ahead.
I have one for E4. I actually, because your answer said that yes, that it is accurate.
Oh, and you will think, okay, let's, everybody take a look at Lou Dobbs, this paragraph right here from Lou. Feel free to ignore the $8.3 trillion. That's not important. In the grand scheme of what, it's important. I mean, it's important because it's our kids who are paying it off, and their kids. But it's not important for the purposes of what I'm asking you right now, which is, can you believe the fact is $200 billion? So I said yes, but I'm doing some ishing with that yes. Chess, tell me why you're saying no. Go ahead.
Well, I'm saying no because if you're paying off what's owed on the houses, it wouldn't matter what the average price of a house was.
I love that statement. Did you hear that statement? That was an awesome statement. She said, if you're paying off what's owed on the house, it wouldn't matter what the average is. I agree with that statement, Chess. I agree that if you are paying off what's owed on your house, the average is pretty much irrelevant because you are probably not the average. But Lou is not talking about you paying off your house. He's talking about the US government paying off all of them. And that's why the answer is yes, his numbers are okay. Hold tight. Hold that thought, because what you said is a key element of answering this question, at least in the understanding of the answer of the question. Hold tight. Let's work it out on the sideboard over here. This is a cool use of the average that you see occasionally from time to time where, well, first of all, what is an average? An average of one, two numbers. What does it mean?
Everybody shares equally.
Say that again, Jesse.
Everybody shares equally.
Right. So in other words, there's a million houses that million underwater houses he's talking about. If every one of those houses owed $206,000, that would be equal to the same total dollar amount owed right now by the by the million houses that are all different monetary values. Some of those houses may only have a $1,000 mortgage on them. Some of those houses may have a $14 million mortgage on them. But when you average them, they average to $206,000. So that's what that average actually means. So what it defaults down to is, here's the computational formula. The reason we like, X bar. The reason we like this is because this part of it ensures the fair share. Add up all the mortgages, divide by how many mortgages there are, and that tells you on average what a mortgage is worth. What's cool about this is he has given you two of these pieces, but not two that you're used to getting when you find the average of a bunch of numbers. So you can ignore the 8.3 trillion. Extract another number from that argument and tell me where it goes in our little formula over here.
206,000.
206, Tammy, right? 206, and where does that go, my friend?
X bar.
That's the average. So what's interesting about this is he's actually telling you $206,000 goes where the average is. Fair enough? Good. Equals, okay. Extract another number and tell me where it goes in that formula. Be brave, my friends. You know it.
200 billion would be what do you call the EX?
Oh, it's summation.
Yeah.
The summation of X. That's exactly right. Tell me your name one more time.
Tabitha?
Tabitha, that's right. Can I do a favor, Tabitha? I want to leave that 200 billion out for a second. I want to leave it in a big box. I'm going to call it the unknown. Because the thing is, we're trying to decide if we believe his 200 billion or not. So I think what Tabitha has pointed out here is, whatever goes in this box is the amount Lou should have quoted. That's the amount he should have quoted. Let's not put the 200 billion there just to see if it's actually the correct number he should have quoted. Is that fair? Mm-hmm. So the only other number up there besides the 8.3 trillion is the million. And what is that? That's how many houses there were, right? So here's houses. I'm going to put some units in here. There's houses. This is $206,000 per house. I mean, the whole idea of that unit is per house. On average, per house, $206,000 is owed. Okay, it's an oversimplification, as Chess has pointed out. Okay, so now the question is, what value should Lou have set for the overriding cost of all these underwater mortgages? As Tabitha correctly pointed out, it's the number that goes right here. Because as you said, what is this big E? Absolutely, it's capital sigma, it's the S sound for sum. So whenever you see that, it means you're adding a bunch of stuff. Well, each one of these X's is standing for what, friends? Be brave, be brave. It's a mortgage value, isn't it? It's one of the mortgages. So you're adding them all up. Well, that's the number he's quoting. Let's see if it's correct. Can we figure out what's supposed to be here based on these two numbers?
206 million.
Exactly. So what he did was he took this million and multiplied it by this 206,000. It basically solved a linear equation. You got x over this equals this. So multiply that, and you basically add 6 zeros to it. So you're going to end up with 206 with 6 more zeros equals the summation of x, which essentially, as Tabitha correctly pointed out, is the dollar amount in total owed on the underwater houses. Chessa, back to you. Does this tell you what your house owes? Or my house owes individually?
No, I think maybe I phrased that question wrong.
No. I love the way you phrased it. You phrased it correctly.
Well, because I didn't mean about the average house price. I meant, why would you care about the price of a house when you're worried about the paying off debt?
Because the debt is what got us into trouble, according to Lou Dobbs. The value borrowed, the amount borrowed against the house is what got us into trouble. The fact that people couldn't pay off those loans. So his claim was, for 0.2, now he called it 200, but he dropped the 6. Everyone okay with that? It's okay, we just dropped $6 billion, right? Depending on the little time. So he called this 200 billion, which is why I'm okay with the 200. He's saying that's 0.2 trillion dollars, which it is, right? A trillion would be one more space. This is 0.2 of a trillion dollars. So he's saying, and I don't know where he got the 8.3 or 8.5 trillion dollars from. I have no idea where that number came from. I'm guessing it's one of those deficit debt. I don't know. The numbers get too staggeringly huge. But his point is well taken. If this overly simplistic view actually works economically, his point was, take this very small part of the 8.5 trillion, buy up all those toxic assets, deal with them at a governmental level with penalties and stuff like that, and prevent those houses from going belly up and therefore infecting the entire system. That's what he was after, Chester. That's all he was after. But I'm not even after you being after that. I'm after, is that number that he used okay? And it is. It is based on this argument. Is that fair? I love the fact you're going into it more deeply. Economically, thank you for that. But all I'm after is the actual use of the average there. Tabitha, you got a concern, go ahead.
Well, I was just going to say, we're assuming that the people that bought those houses never paid anything on them?
Well, again, that would be taken care of with the average.
Okay.
That's the average. I'm assuming the average left owed on each house. So in other words, it's not an average taken out of 206,000, it's an average balance of 206,000. That's the way I read it, because he said average price of a house. He's basically swapping that with the average value of the house mortgaged.
Right.
So he's being a little cavalier with that figure too, but I assume that whatever the balance left on the house is that amount. So yes, I mean, there's definitely some fine-toothed combs to pick through. But again, we're ignoring the combs and looking at the big, beautiful head of hair that is that $200 billion and making sure that the numbers he's using, assuming they're correct, generate $200 billion. And I think we just said that they did. So we're happy. Well, ish. At least we're content. Happy is a tricky word in math class. Is that fair? Yeah? Good. This use of average pops up from time to time. You'll see it. You'll see it quite often. It's a good way of getting a sum of data, which is very often what you want. It doesn't help us, as Chester said, with an individual house. But it will tell you how much money, for example, is in all the houses. Or as I told the other class years ago, I remember going on a mountain bike trip with some friends. We were out for 4 hours. And I said, we used to have little computers on our bikes back then. I thought that was cool. Little bike computers, little magnets that spun. Now we have iPhones. Anyway, and at the end of the ride, our average speed was 12 miles an hour. And we were out for 4 hours. And I remember being all proud about that. We averaged 12 miles an hour for 4 hours. I told my buddy Matt King, so you rode for 48 miles? I'm like, nah, we rode like 22. Where did you get 48 from? Then I realized we were out for 4 hours, but we weren't moving the entire time. When you added up the number of miles that we traveled divided by the amount of time we were actually moving, it averaged 12 miles an hour. But we were only moving about 2 of those 4. If you ever get in a bike ride with a bunch of guys, a lot of BS happens. But you can't jump that log, but I can. Oh shoot, yeah, I mean, there's all kinds of stuff that happens besides riding. But the thing is that Matt was able to reverse engineer from an average speed of 12 miles an hour and 4 total hours, how many miles I had gone. Or at least how many miles I claimed to have gone, assuming I was riding for 4 straight hours. So, fair-ish? So in other words, sometimes you want this. Sometimes this is meaningful to you. And if all you've got is this and this, you can get it. You can get it. Yeah. That was just a great example of it from the median, so. Yeah, get a little dated, unfortunately. I wish I had more time to watch the news. I have a 5-year-old really dampens watching news. I mean, it's fun watching him, but like, he doesn't talk about averages all that much. He does things like Transformers and He-Man and stuff like that. Spider-Man. I'll work out averages in Spider-Man somehow. Lucas!
Did you hear about the bomb that just went off in Boston Marathon? Right before
Oh my God.
Right at the end, right at the
No.
finish line.
The stock market took a big dive on the news.
A bomb went off at the end of the marathon.
Not very long ago.
That was like a few hours ago.
Oh my God, no, I did not hear
So
that.
that was the news. Just
The last I heard was the guy that was in the lead at mile 7 ran a mile in 4 minutes and 43 seconds.
Holy cow.
Remember, they run 26 of those, and this was the 7th. I can't run one of those. I can barely run half of one of
I have a
those.
friend, his name's Tim.
A bomb went off. Oh my God.
They have 2 bombs, it was actually 2 that went off right at the.
2. Good Lord.
People got killed apparently.
They don't know
There's
if
all
it's
kinds of
terrorist
stories
activity.
where.
Or, yeah. Well, it is. It matters who did it, I guess, right? No, I did not. Crap.
So be happy you're not watching the news, because that's.
Well, maybe, right. Yeah, there's plenty of stuff to talk about in the news besides terrorist acts. Okay, I'm happy I'm not watching the news. Of course, now I know, though. Damn you, Ali.
Sorry.
So, anyway, cool? Yes? Jessica, feel better about it?
Yes.
Good, excellent, excellent. And like I said, I always want you guys to be critical consumers of media. So I love the fact that you're critically consuming the average price of a house versus amount borrowed versus all that stuff. Totally awesome, totally awesome. But really, in this one, I'm just going for a big picture. A big picture for, is that number believable based on his other values? Anything else give you grief in there? Anything else give you agita? Hives? Lord, agita. Give me agita. I'm Italian. That's what my grandmother used to say. Agita. Agitation.
Oh, okay.
Agitation. You're too
Where's the-
skinny. Yeah, all the stuff we started with my grandmother.
Skinny.
Rest in peace, Mary. Beth, please.
Just real quick, what's the difference between a median and a mid-range?
Okay, great question. Sometimes there isn't. Sometimes there isn't. So a median, give me words for a median, friends. What is a median? When I ask you, like for example, up here with this dot plot of data, I couldn't ask you for a median on the house prices because you actually need the raw data to kind of get it.
The middle number?
In what way? I love that, Shelby. In which way? Wait, Shelby. Is that right? Shelby, okay, good.
I just think of like every time I think median, I just think of you chopping.
Perfect. So you're talking about the literal geographic middle with not respecting how far out they are. Love it. So you're chopping, you're chopping, you're chopping, you're chopping. So it's the geographic middle versus the average middle, which is the balanced middle. Now sometimes they're all the same. Beth, the mid-range is when you look at the outside most values and figure out what number is directly between them. So in this case, it would be 4.5, because your smallest data point is 0, and your largest data point is 9. So in the middle of that is 4.5, directly between them. I ignore the mid-range for the most part, because it only behaves as a believable value, usually when you have symmetric data with not a whole lot of outlier activity. As soon as, for example, if we look back at this data set and try to do a mid-range calculation, which we just did, suppose you had a couple 9s, a couple 8s, and then maybe increasing as you got over to here. So you got this hump over here, then you have this tail that goes out here. This happens all the time, by the way. I mean, your guys' exam scores are skewed the other way. Usually you've got a couple low scores and they skew up to this beautiful hump over here on the high scores. Well, the mid-range doesn't do a very good job of describing what's going on at all, because it gives you the superfluous value in the middle, which is actually to the left or right of where most of the data is. So I've tended to ignore the mid-range because of that. It's just one of those things. They love piling in measures in textbooks for center, I think because they're easy to calculate. But I'd rather focus on 3 of them that are meaningful to calculate. I mean they're all easy, but most of them meaningful. Please.
On one of the homework questions,
Mhm.
what if they're asking for a mode and you don't have a most common number, then what?
This goes back to Jess's question too. Just put it doesn't have one.
Okay.
Or if you want, you can say they all are, because they all occurred one time. Your choice. Your I would say there are none.
Okay.
And I think that's pretty much common practice, not to use Excel as a stat reference, but if you grab a bunch of data in Excel and tell it to find the mode and they're all unique, it'll say not applicable.
Okay.
And you'll learn how to do that in Excel in your first take-home exam. I'll have you guys mess around with that. But yeah, to your choice. I think it's easiest to put not applicable, doesn't have one, or something along those lines. Cool? Good. What else gives you grief? Feeling okay? Yeah, centers are cool. I mean, averaging is cool because it gives us that idea of typical, usual. Somebody said equal shares. Is that you, Lucas? Equal shares?
I think so.
Yeah, that's a great way of thinking of it. $206,000 house value. If every one of those 1 million houses costed exactly the same, they'd all have to cost $206,000 to accrue the same amount of debt borrowed against them as they are now. Now, I love centers. I love center measure. The problem with center measure is it's not enough. And I want to go back to our friends Bert and Ernie to talk about why it's not enough. I want to go back to our friends Bert. Mute the stream. You bring some light up a little bit. Blank screen. Let's see if I can make this work. Sometimes these just shut off on their own. I haven't figured this room out yet. All right, so I need your guys' help real quick here. Okay, yeah, that's great. It's got a braking system. So we had Bert and we had Ernie. Remind me of their test scores from last time.
Bert is
They all-
Bert, Jess, go ahead. 100?
68.
68?
82.
82?
94.
94?
61.
61. Beautiful, beautiful. And Ernie, if you don't mind?
81.
81?
79.
79?
83.
3?
82.
2?
And 80.
And 8. Thank you, my friend. Okay. And I asked you what seemed like a simple question last class. I said, which of these is the better student? Who did we decide was the better student?
Ernie?
And there is no correct answer. Oh, I shouldn't say it. Sorry. There's no one correct answer. I heard some Ernies. Tell me why Ernie is the better student.
He's more consistent.
Okay, so we like Ernie
Consistency.
is consistent. I like that. Which means that Bert is more inconsistent. I like that. Inconsistent. Inconsistent. Good. If I had to ask you to rate consistency, how much more inconsistent is Bert than Ernie? How would you do that, do you think? How much more inconsistent is Bert than Ernie? I'm not saying this is an easy question to answer right now. I'm not saying that at all. Say that again. Say that again. Athena?
I said 1/3.
He's 1/3 as consistent? Tell me why. That's kind of a cool number.
I don't know.
Okay, just gut, chicken the gut.
Well, it's not quite half.
When you say it not quite, what are you looking at?
How many times he screwed up and got Fs?
Oh, okay, so you're kind of applying a limit somewhere. So these are the screw up. So okay, so you got 5 data points.
Yeah.
You're calling this a screw up and this a screw up?
Yeah.
So he screws up 40% of the time. He also kicks ass 40% of the time.
Yeah.
And the problem with this, of course, is did anybody vote they're the same student?
Well, we said they get the same average.
That's the problem with the 40% screw up versus 40% kicking ass. Whereas Ernie's kind of 100% lukewarm right in the middle. And that was the problem, right? If you look at both of them, for Ernie, his average, I believe, was 81. I think all of his measures were, weren't they?
Yeah.
And even, do we do the throw the top and the bottom away and recalculate? Did we do that one as well?
It still was the same.
And it was still the same, exactly, Athena. So we got a trimmed mean. Yeah. So they're all 81. And I think what Athena just pointed out is one of the more interesting things about Bert's data set. If he screwed up twice, he kicked ass twice, and he middled once. So basically, the 2 that he kicked ass on cancel the 2 that he did not kick ass on, and he balances out being essentially the same as Ernie. Now, for Ernie, it was 81, 81, and Bert's not exactly the same, right? I believe his average was, I think his median is 82. Now, remember, just to be careful, the median is the middle score when arranged in order. It just so happens 82 is in the middle of these 5 numbers, but you'd have to go 61, 68, 82, 94, 100. And his trimmed mean was a little bit off, only because we did it in the last class. I think it was 81.3, if I remember correctly from the last class. So there's a problem. The problem is that on center, on average, they're exactly the same. So in other words, let's draw a little distinction here. Measures of center. Let me slide the camera a little bit too. Yeah. Measures of center. So, and the words you guys were using, what? Typical. Typical. Balanced. Equal. What other words were you guys using for center?
Even distribution.
Even distribution, love that. Anything else? Share. Oh, I love that one too. Especially with Athena's discussion right now about Bert.